The night sky always has something interesting going on, doesn't it? And this Saturday is definitely one of those times. We've got this thing called a pink micromoon coming up.
Hmm.
Now, for you, our listener, someone clearly interested in digging a bit deeper, understanding the world. This isn't just, another pretty moon.
Right.
It's a chance for us to really explore some fascinating stuff about how the moon works and, well, even how your own perception plays tricks on you sometimes.
Absolutely. Yeah. This micromoon, it might sound subtle, and it is subtle, but it's actually a brilliant launch pad, you could say.
A launch pad, how so?
Well, for unpacking, key ideas in astronomy, how light works, even visual perception. We're not just talking about a full moon looking a tiny bit smaller.
Okay.
We're touching on its orbit, what our atmosphere does to light, and like you said, that amazing, sometimes really misleading way your brain interprets what your eyes see.
Exactly.
Yeah.
So, okay, for this deep dive, we've looked at an article over on earth.com.
Yeah.
We want to really get to grips with this pink micromoon.
Yeah.
What is it? Why does it look the way it does, especially that pink color? And then dive into that always fascinating moon illusion.
Right.
Our mission here, really, is to get past the headlines, give you a clear, engaging understanding of what's happening up there. Knowledge that, well, hopefully enriches how you see things.
And it's definitely timely, especially for listeners, perhaps preparing for competitive exams, maybe like the UPSC.
Ah, good point.
Yeah, keeping up with these events, and more importantly, the science behind them. It all helps build that foundational knowledge about the world. Stuff that can pop up in surprising ways in your studies.
Okay, right. So let's unpack it. First things first, what exactly is a micromoon? What should you be looking for?
Okay, so a micromoon, it happens when you have a full moon, right? And that full moon coincides with the moon reaching what's called apogee.
Apogee. Okay, what's that?
Think of the moon's path around Earth. It's not a perfect circle, more like an ellipse, slightly oval or egg-shaped,
Right. Slightly stretched.
Exactly. Apogee is simply the point in that oval orbit where the moon is farthest away from Earth. So full moon plus farthest point equals micromoon. Simple as that, basically.
So it's a full moon, just physically further away from us, from you. Does that actually make it look different, noticeably?
Precisely. It's further away, so naturally it looks a bit smaller and a bit dimmer than, say, an average full moon.
Mm.
But when we say a bit, we really do mean subtle. There's an astrophysicist, Elaine Brizard from St. Michael's College, quoted saying it's a very subtle difference.
Ah, okay.
You'd probably need to be looking quite carefully, maybe comparing it in your mind to other full moons you've seen or even photos to really spot that slight size change easily.
Got it. So not something that's going to jump out at you immediately, not like a dramatic shrinking act.
No, definitely not.
But there are times when the moon does look significantly different, aren't there? We hear about supermoons all the time.
Yes, exactly. That's the flip side. A supermoon is when a full moon happens at perigee.
Perigee.
Mhm.
So that's the closest point.
That's the one. Closest point in that egg-shaped orbit. And the difference between a micromoon at its farthest and a supermoon at its closest, that can be noticeable to you.
How noticeable?
Well, supermoons can appear roughly 14% larger and, get this, about 30% brighter than a micromoon.
Wow. Okay, 30% brighter.
Yeah.
That actually sounds like something you would notice, even if the micromoon's dimness is subtle for you.
It is, yeah. It can make a difference.
So how often do these things happen? Micromoons, supermoons. Is this Saturday's event like a rare thing you absolutely have to catch?
Not really, no. Both micromoons and supermoons pop up several times every year. It just depends on how the timing works out,
Yeah.
The full moon phase aligning with those far apogee or near perigee points in the orbit.
Right.
In fact, you've got this micromoon Saturday, then another one coming up in May. And later this year, look out for 3 supermoons, October, November, and December.
3 in a row, okay.
Yeah. So they're regular celestial events, really. Plenty of chances for you to observe them throughout the year.
Okay, that definitely puts it in perspective. So now the pink part, a pink micromoon, is the moon actually like changing color up there for you? Is it blushing?
Huh. That's a great question. And the answer is, well, not really. The pinkish look isn't about the moon itself. It's an effect caused by our own atmosphere, Earth's atmosphere.
Huh.
And it usually happens when you see the moon low on the horizon, just after it rises or just before it sets.
Oh, okay, like when the sun looks really red or orange during sunrise or sunset for you?
Exactly the same principle. Spot on. When the moon is low, its light has to travel through much more of Earth's atmosphere to reach your eyes.
Right, a thicker slice of air.
Precisely. And that thicker slice acts like a filter. It scatters the shorter wavelengths of light blues and violets, that sort of thing, away.
So they get filtered out.
They get scattered in different directions, yeah. So what's left, the light that makes it through directly to you, is richer in the longer wavelengths. Reds, oranges, and yes, sometimes pinks. That's what you end up seeing.
So it's our atmosphere painting the moon pink for us, basically.
You could put it that way, yeah. And the effect can be stronger if there's more stuff in the air, like dust or pollution.
Oh, interesting.
That can intensify the scattering and make the moon look even deeper red or orange to you. You might remember seeing really vivid sunsets or moonrises after, say, a big volcanic eruption. That's the same kind of atmospheric effect you're witnessing.
That makes sense. Like, remember that lunar eclipse back in March?
Mm-hmm.
The moon went this deep, coppery red color for everyone watching.
Yeah.
That was atmospheric too, wasn't it?
Absolutely. That deep red you saw during the eclipse was sunlight filtering through Earth's atmosphere and then hitting the moon. So yeah, the pink in Pink Micromoon is all about its position low in your sky and how our atmosphere messes with the light before it gets to your eyes.
Fascinating. Okay, let's switch gears slightly. Something else the article mentioned, which always kind of bends my mind, and probably yours too, listener, the moon illusion.
Yes. The big one.
We've all seen it, right? The moon looks absolutely huge when it's just peeking over the horizon.
Mm.
But the article says its actual size doesn't change a bit. What is going on there? What are you perceiving?
You've hit on a really, really intriguing puzzle about perception.
Yeah.
The moon illusion, it's that very distinct feeling, that observation you make, that the moon looks much, much larger when it's near the horizon, hanging over buildings, trees, mountains,
Yeah.
compared to when it's high up overhead in the middle of the night sky. And you're absolutely right. Physically, its angular size in the sky stays pretty much constant.
So what you're experiencing, it's just a trick.
It's purely a trick of perception, yeah. A visual trick handled entirely by your brain. That's how the article puts it, and it's accurate.
But it's so convincing. When you see that massive orange moon rising over the trees,
Yeah.
it just feels enormous to you, undeniably huge.
It absolutely does. And what's really wild is that even after thousands of years of us watching the moon and all our science, scientists don't fully, completely understand the moon illusion.
Seriously.
Yeah.
Still.
It's one of those fantastic examples where your subjective experience, what you see and feel, doesn't quite line up with objective measurement, which is, a really important thing to remember in lots of areas, especially when you're analyzing information for something like the UPSC.
Wow. Okay, so photos prove the size doesn't change for you, but your own eyes tell you something different.
Yeah.
That's wild for you to think about. The article mentioned NASA has some simple tests you can do to demonstrate it to yourself.
Yeah, they do. A couple of really easy things for you to try. One is super simple. Just hold your arm out, stick out your index finger, and hold it up next to the moon.
Okay.
What you'll probably find is that your fingernail roughly covers the moon or appears about the same size. And that's true whether the moon is on the horizon or high in the sky. It gives you a bust line for its actual angular size.
Right, okay. Kind of anchors your perception of its real size. And the other test you can try.
The other one involves changing how you view it. Try looking at the moon through a little tube like a rolled up piece of paper. Or, and this sounds weird, bend over and look at the moon between your legs.
Between your legs.
Seriously.
Seriously. What happens for many people is when you block out the surroundings, the horizon, the trees, the buildings that you're subconsciously comparing it to the moon, suddenly seems to shrink back to its normal size. It appears smaller to you.
That is so weirdly counterintuitive for you. It really shows how much your brain is using context, isn't it, to judge size and distance. I've definitely had that whoa moment, seeing a rising full moon. Feels like you could reach out and touch it almost.
Exactly. When the moon is low, your brain processes it alongside those familiar objects on the horizon that you know the rough distance to. It seems like it's part of the landscape almost, powering over it. But, like the article says, the moon itself hasn't changed size one bit. It's your mind's interpretation creating that illusion for you. So you see this giant moon low down, and then later that night, high up, it seems. Well, normal sized again. Almost disappointing sometimes. It's like magic, but it's all happening inside your head.
Pretty much, yeah.
Now, the article mentioned theories, but also that there's no single complete explanation. What are the main ideas for what's happening in your brain?
That's right. It's still debated. No single universally accepted explanation for the illusion you experience. But the most common theory, the one you hear most often, relates to how your brain judges size and distance, especially near the horizon.
How does that work in your mind then?
Well, the idea is when the moon is low, you see it alongside things like buildings, trees, mountains, things on the ground.
Okay.
Your brain knows those things are relatively far away. And because the moon, in terms of the space it takes up in your vision, looks large compared to those distant objects, your brain might think, wow, if it looks that big way out there with those trees, it must be absolutely enormous. It
Yeah.
kind of inflates the perceived size for you.
That sounds a bit like that Ponzo illusion with the converging railroad tracks,
That's a perfect comparison, yes.
where the top line looks longer to you even though it's the same size just because of the perspective lines.
Exactly. The Ponzo illusion shows how context, those converging lines suggesting depth, can trick your brain into misjudging the size of identical objects. The horizon objects might be doing something similar for the moon in your perception.
Okay, that makes a certain amount of sense for you. The horizon gives context.
Yeah.
But the article also threw in a curveball. It said, even astronauts in space report seeing the moon illusion.
Right.
How does that work? There's no landscape, no trees up there for you to compare it to.
And that's the really fascinating part for your understanding, isn't it? It tells us the horizon scenery can't be the only explanation for the illusion in your perception.
So there must be something else going on.
Seems likely. The fact astronauts see it suggests there might be other factors, maybe something more fundamental about how our visual system processes objects at great distances, or how you perceive the sky itself as a dome. It really deepens the mystery for everyone, and it shows how science keeps probing, even at things we've seen forever.
So after all this time, you and everyone else has spent looking at the moon, this basic thing you experience, and we still don't entirely know why it happens in your brain. That's-
Wow.
It's both cool and kind of humbling for you to realize.
Right.
Really shows how complex your own perception is.
It really does. It's a great reminder for you that even with all our technology and knowledge, there are basic aspects of just being human, of how you perceive reality, that we're still figuring out. It touches on consciousness, how your brain builds the world you experience.
Okay, wow. So we've covered the micromoon, full moon apogee, a bit smaller, a bit dimmer for you. The pink, just atmospheric scattering when it's low in your sky. And this incredible moon illusion, the horizon trick your brain plays. Why does this matter to you, our listener? Why spend time on this?
Well, think about it. For someone like you, invested in understanding things, maybe preparing for exams like the UPSC, these aren't just isolated facts. They're windows into bigger scientific principles that are absolutely relevant to your studies.
How so?
We've touched on orbital mechanics, how things move in space. That's physics. We've talked atmospheric science, how light interacts with air. That's physics and environmental science. And then there's the whole nature of perception, psychology, even philosophy of mind. How reliable are your senses? How does your brain interpret data? These themes cut across so many subjects you need to grapple with.
Right, so it's not just memorizing micromoon. It's understanding the why behind it, the physics, the perception, skills that help you think critically in a much broader sense.
Exactly. Understanding the elliptical orbit connects to basic astronomy you might encounter. Understanding the atmospheric scattering helps you grasp other phenomena, maybe related to climate or pollution, crucial for your environment syllabus. And grappling with the moon illusion. That forces you to think about evidence, perception versus reality, cognitive biases, skills vital for analyzing information, constructing arguments, tackling essay questions across the board.
So it encourages that deeper level of scientific inquiry and critical thought for you, even from just looking up at the moon, seeing past the obvious and connecting dots, which is key for your learning.
Precisely. It prompts you to question, okay, I see this, but what's really going on? That questioning mindset, understanding that perception isn't always reality, is crucial for you when you're evaluating sources, analyzing complex issues, separating fact from interpretation. Even a simple look at the moon can hone those analytical skills.
Okay, great point. So let's quickly recap for you. This Saturday night, micromoon. Full moon, furthest point from Earth, looks a tad smaller and dimmer to you. If it's low on your horizon, maybe a pinkish tint, thanks to Earth's atmosphere scattering light before it reaches your eyes.
Right.
And always remember the moon illusion, that powerful perception trick making it seem huge near the horizon, even though you know its size hasn't actually changed.
And the why of that illusion, the full story you experience, is still something science is working on. A neat little ongoing mystery.
So yeah, this Saturday, if you get a chance, definitely step outside. Take a look at the Pink Micromoon. Maybe try those NASA tests for yourself. Hold up your finger or look through a tube. Experience it.
It's a great way to connect the concepts directly to what you observe.
And maybe just maybe, it'll make you pause and think, you know, how often do my perceptions maybe differ from objective reality? How important is it to dig deeper than just the surface observation?
That reflection, that critical self-awareness is incredibly valuable for you, especially when navigating the sheer volume of information you encounter in your UPSC preparation and beyond.
And specifically for you, our UPSC aspirant listener, remember that connecting these dots, orbits, atmosphere, perception, through examples like this, it builds that solid, comprehensive foundation that really helps in the long run. It's not just about isolated facts, it's about understanding systems and principles.
Well said. It strengthens your overall analytical framework.
So if you found this deep dive into the micromoon and moon mysteries useful or interesting, please do hit like and subscribe for more sessions like this, tackling important topics relevant to your prep.
And definitely leave us a comment. If you have questions, thoughts, your own observations of the moon illusion, we genuinely love to hear from you.
We really would. Your queries help us shape future discussions too.
Mm-hmm.
And finally, just to be clear, today's deep dive drew its information primarily from an article on Earth.com.